Good morning, everyone. My name is Manvi, and I'll be your host for today. Thank you for joining us on this webinar, where we will talk about how to achieve smart data sharing with Snowflake. First things first, we will take all the questions at the end of the webinar. If you have any questions, click on the question mark at the top right to submit your questions. We will share the webinar presentation with you within 3 to 5 working days at the end of this webinar. Let's get started. Our presenter and speaker for the day is Mr. John Ebenezer. John Ebenezer is the Vice President Data Practice Head at Communal Digital. He's a strong visionary leader in an evolving technology landscape with a track record of inspiring excellence, more focus on performance, business development, and innovation with over 20 years of experience in data analytics, big data, data management, data warehousing, and business intelligence. He has led several large data engagements for Fortune 500 clients across various industry verticals like BFSI, retail, manufacturing, healthcare, to name a few. Over to you, John.
Thank you, Manvi. I welcome you all. It's a great pleasure to share today's topic. So, as Manvi said, as I talk through, if you have any questions, do ping, so I'll try to address that once I complete the session. And hope we have, glad to see that you have joined to hear some of the trending technologies and the features in Snowflake that they have launched. So I'm really excited to share, and hope you will enjoy it, and it is going to benefit you. Having said that, for today's agenda, let's see what is data sharing and some of the use cases, and why data sharing in Snowflake is so special and unique. What were the challenges that the traditional technologies were not able to address? What is the kind of approach and the methodology that the traditional world followed, and how different it is with Snowflake? So we're going to see the differences, and we will also see how easy it is to implement it with such a large volume, reaching out to such a large number of users, where you are effortlessly sharing the data across with your customers, or even the users or the consumers. So we will also see how the entire framework of this data sharing works, and how it is implemented in Snowflake. Followed by that, we will have a case study, so which we recently implemented, and then we'll get on to the question and answers session. Yeah, let's move on. So let's talk about the legacy data sharing challenges. So here, so before I talk about the data sharing challenges, what exactly is a data sharing? Basically, there is a lot of data being generated today, and we see when we compare, or when we go back about 10 years back, we find data being generated only through applications, systems, which is fully digitized. And today, after having these IoT devices, sensors, there is tons of data being generated today. And today's statistics says that there is at least 30 terabyte of data being generated per second. And imagine the volume and the velocity that the data is growing or being generated through various devices or applications. And now it's not about generating the data. The challenge is now, how do we extract the meaningful information? How do I have this data-driven insights out of it? How do I get this in a timely manner so that I can action upon it? So that is the challenge. So data sharing is, as it is self-explanatory, it is more about how one produces the data and how he can present the data or share the data with his users. It can be an internal user, and external users will be customers who are outside, and so on. So basically, we are trying to share not just the data, but the data which is something that can be queryable, that means to say, which is in a readable form, that can be used for the consumers in a way that they can action it. So when we say about sharing, it's not about really a raw data that is generated. So here, when we want to share some data, there should be some meaningful information in it, such that the end user who consumes that will leverage or will make use of it. So in a traditional world, this required, so where we had stored the data in one or more servers, and it was through the network that we had to extract the data, and there is a lot of processes involved before it reaches the end user. So, and as I said about the data sharing the useful information with multiple users or the end users, so that they can leverage that and use it for their activities or business activities, or taking data-driven insights or actionable insights. So now let us try to understand what were the challenges earlier, before we had this luxury of leveraging this feature or the product in using the data sharing technology. So let's move on to the next slide. Before I talk about the use case, so this is mainly talking about one of the healthcare use case. So I want to talk about in detail of one of the challenges that the traditional world or the traditional data world is facing in sharing the data. One of the primary reason is there are too many data which is in silos, and the effort and the cost to consolidate that and making it available to the consumer is very high. So this is because of the limitation with the kind of infrastructure that we have, and the data is scattered across various systems, and it is in silos. Identifying them, consolidating them, and making it available is an expensive one. So the other aspect is the data is growing, and when the database is too large, it is practically not possible with a traditional technology to share such a large volume. So that is another challenge. The other issue is, even if we are able to come up with a strategy to share that, the time to really extract the data, to cleanse, consolidate, massage the data, bring it into the shape that is usable, it takes a lot of time. It takes a lot of resources and effort to really produce that kind of outcome before we share the data. And the primary reason why people are moving away to a latest technology or finding a way to share the data is how simple, easy, and cost-effective is it. It is. So traditional way of sharing the data is having a lot of challenges, and one of the primary reason is it is so expensive to really manage such a large infrastructure with number of resources and the maintenance of that. So having said that, now why and where data sharing is widely used. So here is one of the healthcare use case, and primarily where data sharing is enabled, where a producer is someone who owns that data, and he now wants to share that data with his audience. The audience could be his immediate customers, and could be an external customers. It can be internal customers within the organization, and so on. So it is, if you see some of the industries where data sharing is becoming very popular, is the gaming world is gaining more popularity in leveraging this data sharing to share the data that they are producing across with various users. And there are a lot of other use cases where there are a lot of data aggregators, particularly in the healthcare and life sciences. So there is a lot of medical data or patient-related data that is captured across, and they are leveraging that to connect between the researchers, the laboratories, and the diagnostics, and so on. So there is a lot of data aggregators leveraging this service of how we can produce or generate and make the data available in one place, and that can be shared across different departments in the healthcare sector. And if you look at the automobile industry, so today we see there are a lot of telematics, which is one of the technology which is in the automobile industry, where for every kind of activity that is performed within the vehicle, there are a lot of sensors. The sensors to measure the speed, the driving behavior, the pattern, and the miles they have driven. And where they are. So all this information are captured through the sensors today. And today, this data is being collected, and this is provided. It is this data is being shared with a lot of trucking companies today. They consume this data to plan their fleet and know that where, in which location, what vehicle is, and all these in a near real time. They're able to get the information that is making them to action at the right time. So this is saving a lot of cost, and they are efficiently utilizing the vehicles in planning and scheduling. So the other area is in the advertising world. Since there is a lot of organizations, they are running the campaigns and they want to measure their performance with a cost per impressions and clicks and cost per impression that they want to measure. So this is a very big volume of data that when they are actually running the campaigns across various services or various lines of businesses, when they want to measure, they want to collate this, and they want to share how they are performing with their respective consumers. So having said that, so these are some of the use cases in the data sharing world. So let's move on next. Hope we now got a very high level. And some of the other challenges that apart from what I was talking, so from the technically speaking, the data sharing challenges with the traditional world is having the increased data size and the growing data size, and data being duplicated, redundant data made available in various places, and not knowing which is the right one to pick. So that is one of the challenge. Data is being generated in different file formats, not consistent with other file formats in while sharing the data. And the time taken to get this data and translate and making it available to the consumers is very time consuming. That is where there is a challenge of making the data available in real time. And some of the data security concerns. So one of the primary reason is in the traditional world, when you want to share a data, you need to move the data. You need to make a copy of it, and then you have to move the data to the target, to the destination. And until it reaches, so you are literally transferring the data over the network and making sure a copy of the data is written on the destination, the target, before they consume or use that. And there are a lot of compromise with the security, and that is one of the concerns with the traditional technology. And the cost to really bring that data sharing is so expensive, considering the time, effort, and cost to implement it and to maintain it is very expensive. And let me explain the process of how exactly it is done in a typical traditional world, and so you'll understand more about what are the challenges we face when we are actually moving the data from the source to the target. Let's go to the next slide. Yeah, so this is an approach. This picture is more talking about in a traditional way how we can move or share the data with a consumer. So you can see the data producer is the one who is actually generating the data or producing the data, and the data consumer is the one who is consuming it. So the challenge of the traditional approach is there are different ways we are transferring the data. It could be through FTP, through an email, through an online file sharing, or through an API call, or even most of us today, we use ETLs for data transformation and loading it into the target. And we can have online storages, which is shared and accessed by the consumers, and so on. As I spoke about the challenges in moving, you can see that the blue database icon here, and you can see there are small squares. This is nothing but the piece of data. In order to move this, we have to make sure that this data is again copied and written into the target. And there was no way without having the data being moved to the target that the data consumer could consume that. And the process of moving this data is the biggest challenge. and as the volume increases, the bigger the size, more the time, more the effort, more the cost. So it is a challenge when the volume and the velocity of the data is increasing. We have much challenges in having this successfully transformed to the destination. So now let us see, even if I want to copy this data to the consumer, to make it available to the consumer, there are certain processes that follows, and that process is again so tedious before it reaches the consumer. So let's see how in the traditional world, how the data is actually passed before it reaches the consumer. Let's move on to this. So this is a typical workflow in a traditional approach of how we would move our data from source to target. You can see that this picture is more explaining about, on the left side you have the source data, and if you want to have this data shared with a target, and on the target you need to have another database, and the way it is moving is, it could be either through CSV or file. We saw different ways. So the data is now extracted, and the extracted data has to be encrypted. So to make sure that we have appropriate security on it, to make sure that the data is not misused, and then through the FTP, you can see that the data is moved from one network to another network. So once that is moving to through the FTP, you are able to move the data on the destination side. The data that is now received has to be decrypted. That is something called as you are to construct the data and deconstruct the data, so before it can be consumed. So now here you can see that the data is decrypted, and then once you have the data in the form readable, you load it into the target. So you can see that the time and the effort and the kind of process, the different steps involved from the point of reading the data from the source and all the way moving the data to the target, we have different points, and there is scope of failure at each of these points. So if let's take the first step of the FTP. If there is a network downtime, so the transfer, the file gets corrupted, that means to say the transfer fails. There is high chances that the transfer, the movement of data gets broken there. So decrypt is so now you got the data. Now you need to the encrypted data has to be decrypted. What do we mean by that? So now, in order to bring it into the readable form, there may be chances that when you are not identifying or having that right algorithm, so there are chances that even decryption that could corrupt the file are not unable to decrypt it, and thereby we lose the content. So, and obviously when we are loading and loading the data, there is a lot of chances, and we encounter in our daily life, when we are loading, there are multiple reasons why data fails to load. And even when we are loading a very huge volume, like we do a reconciliation to check that whether all of this data is loaded, and what are the error rate, what is that the completeness of the data being loaded into the target. So there are high chances of errors when we are loading the data. So the point here is, we have various points or various phases or stages before the data gets transformed from the source to the target, and there are high chances of failing at each of or any of these points. Which is, imagine then when you are trying to share a very large volume of data, and what will be the error rate, and will we be able to copy all of this data at once when it is running into several GBs and several terabytes. So now how is this being overcome with the latest Snowflake's data sharing technology? Or let us go discuss about those points now. Let's move on to the next slide. So the plan now is to use a modern approach of how I can move the data from source to target, or have the data being shared from source to the target. So if you see the whole idea behind the data sharing is not to just lift and shift the data as it comes. So basically, you generate the data, which is basically the raw data, and now you work on it to produce or shape it and model it, bring it into a meaningful form, which is an information that can be consumed by the consumers. So that is where here the concept of data sharing brings in certain services to transform that raw data into a meaningful or the useful information, which is a value added data, which is information that can be consumed by the consumers. So now, how has this been implemented or designed? Let's look into that. So here is what the way in Snowflake, so how the data is produced and the way it is going to be made available to the consumers. So the provider is the one who is actually producing the data, and he is sharing the data. That means to say he is making the data available to the users, and that users, or we call it as consumers. The consumers can be either internally used, which is internally within the organization, or it can be the external direct markets, or it could be an external adjacent markets. So the point here is how far we are able to reach by sharing this data, and that is what is the ability of this the framework that has been designed for data sharing, and how quickly, how easily we can have this data shared. So now the question is, in the traditional approach, we had to copy the data. Without copying the data into the target, it was not able to, we were not able to share it. And how is this different here? How is it different here? And what is it making it so special and easy that is making data sharing a very unique capability or unique feature in using this service? So let's get on to that. Let's move to the next one. So if you had seen a typical Snowflake architecture, it is this component. It has got 3 layers. One is the storage layer. So just before talking about the internals or the depth of the data sharing, let's try to understand how Snowflake as a architecture, the underlying architecture is, for better understanding, so we understand how the data sharing is functioning. You can see here in the middle part, so you can see the centralized storage. The unique feature that Snowflake brings in is, compared to other data warehouses, is it has isolated the storage and the computing system, the compute. So you can see that the centralized storage is the storage, and always make sure there is only one copy, and this data is shared with different, or it can be processed by different computes. And this compute is called something called as virtual warehouses in Snowflake, and that is the second layer. In the second layer, if you can see, the first internal one is the storage layer. The second one is the compute layer, where you can load the data, perform the analytics, and all the development stuff. So that the compute layer is again, Snowflake has wonderfully come with how you want to, what is the size and the compute power you need based on the kind of data you want to process. So there is small, medium, large, X large. So what are those? So, and Snowflake intelligently identifies based on the query that you fire, and that stats, the execution plan says what number of rows you're going to read. And if that number of rows you're going to read is very small, it will pick up a small size virtual warehouse. And if the plan is suggesting that it is returning a high volume data, then it may suggest either a medium or a large virtual warehouse, accordingly, to make sure that your performance is not degrade. It chooses the right compute power to process that data and return it. So the third layer where you see here is the cloud services layer, and this is the intelligence that Snowflake has built, where when we compare this with either a Redshift or an Azure Synapse Analytics. So you can see that there one has to manually go configure, maintain, scale up or scale down the services, either the nodes or the clusters. It is all manual. One has to configure it before you have to consume. And this part is completely automated, and the layer here has the intelligence to identify based on the query. So it leverages the service that Snowflake has built here. So you can see that you don't have to explicitly do performance tuning, because there is an optimization component in this. And there is a resource management. There is a transactional, there is security enabled, there's a metadata component, and the newly component which is now added is the data sharing. So the outer layer is the cloud servicing layer, which enables this. So now, having said this, now let me talk about, hope you got a high level understanding of how Snowflake is functioning, how the compute is now isolated from the storage and allows multiple users to access the same data without having any kind of interruption or performance degrade from one user to another, though they are accessing the same data, but they are processing the virtual warehouses that they are using as independent. Having said that, now you can see that the data providers here are now producing or writing the data, and they are making available, the data is made available in a centralized storage here. And the compute engines, here you can decide on different sizes. So how, whether you want to go for a small compute power or medium or a large compute power according to the data that you want to process. And now the data sharing part is what the producer who has now generated the data, produced the data, and he can now have this data shared with multiple users. These are nothing but the data consumers. Now let's see what is the underlying architecture of how this data sharing is implemented. Let's move on to the next slide. Yeah. So how? So here now, all this while we were talking about Snowflake data warehouse, and now comes a new term called data share house. So what is the difference? So data warehouse is something that where we host the data, and data share house is a concept that Snowflake has now given when they are actually sharing the data with their consumers. It could be internal, it could be external. It is the outside world. So here, this architecture, this diagram is explaining about how the data is being shared with the consumer. So let us get to the a high-level understanding of what is happening here. So you can see that on the left side, the provider is actually generating the data, and the data generated on the other side, the consumer is trying to create a DB from the share. So what does it mean? So the data share, when he is sharing the data, he is not sharing the actual data. And this is the unique feature or capability that Snowflake brings in here. In the traditional world, we had to copy the data from source to the target, whereas in Snowflake here, we are not actually copying the data. There is no data movement at all. So we will see that in the next diagram, clearly explaining of how it is. So primarily what happens is there is something called as DAC, data access control. So the data access control layer, that is one of the services that enables the users, basically we call it as an account that is able to read from the provider. So the provider can, the account, which is basically the compute power, which is the virtual warehouses. So that account which is able to read the data from one database can now be able to read from other databases as well. So how is this being controlled? How is this access controlled such that the provider can share a specific data to the right consumers that he intends to? And this is where the data access control, the DAC layer, comes into picture, where we define what you want to share, who is the right person who is authorized to access, and it is completely controlled there. And that is what makes the sharing more secure between the provider and the consumers. So this is a very high-level picture of the Snowflake sharing a provider and the consumer concept. And there is something called as when the consumer consumes it, there are two types of consumers. And you can see that there is a reader accounts and a full consumer account. So what is the difference between this? First thing is the Snowflake, this provider and the consumer works on only the Snowflake environment. And therefore, when the Snowflake as a producer, he shares the data, either the consumer should already have a Snowflake account to make sure that he is able to create a database out of the share, because he is not actually having a copy of it. He is trying to connect to the producer database, and what he creates is just the metadata. The metadata, what he creates here is just pointing to the data. So there is no copy made in the consumer end. It is just referring to the actual data where the producer has stored the data. And when the consumer is now not a Snowflake, if he doesn't have the Snowflake account, or if he is not a Snowflake customer, so now how does he actually consume the data? In that case, the producer will create a consumer account, which is reader consumer accounts. The reader consumer account will be created within the producer itself, and this account details would be shared, and the consumer would be able to use that service, and he will be able to read the data that is shared. And if the consumer is having his own, or if he is a customer of Snowflake, he would already have his own account, and through his account, he'll be able to read the data. Now, what is the difference between this? What is the difference between the reader account and the full consumer account? In the full consumer account, because he is already a Snowflake customer, he has already got his own Snowflake database. And now, when he is trying to create a DB from the connecting to the producer's data, he is only creating a metadata. And this metadata is allowing him to read data which is now stored in the producer end. So the consumer will pay not for the storage, because he is not physically storing the data. He will only pay the data for he will only pay the price for the query that he is running, and that is how Snowflake is making money. And whereas on the producer side, since the producer is storing the data, the producer will pay for the cost or the charge he incurs is only on the storage. And now, coming to the reader accounts, if he is not a Snowflake customer, what happens is, since the reader account is also created in the producer's end, the consumer who is using that service to read, and whatever charges, whatever consumption charges that incurs from the consumers, the producer can invoice it to him. So that is how it works. So that is the difference between a reader consumer account and a full consumer account. Having said that, let's get into the depth or details of how this metadata mapping is happening and how it functions. Let's move on to the next slide. I think we went back. Go to the yeah. I believe you are following, and you may have some questions. So if you have any questions, do ping there. So now let's try to get into the understanding of what exactly or how exactly the sharing is working here. You can see that you have a master database at the producer end, and you have the data physically stored in this database. And now, in order to access this data, you can have multiple accounts, multiple virtual warehouses that can connect to this same database and process. Say, you can see that in the top, you can see this indicates that a small virtual warehouse and a medium one and the large one. So based on the need, based on the kind of processing, the compute power, based on the virtual warehouses that we define, so that virtual compute or virtual warehouse connects to that database and reads and processes the data. And now, if you notice on the other side, on the consumer who is actually want to read the data or you want to consume the data, he is only having the metadata. He is not actually having the copy of the data. And how is that possible? So that is the concept I explained about the DAC, the data access control layer, providing the here when he only gets the structure of the data that is being shared. So he creates the metadata, and through the DAC that is data access control, he is able to connect to the original source. That is, he is actually reading the data and he is now consuming. And this data sharing is happening through a secure view. So you can see that the data is not physically stored in the consumer end. It is just the metadata, and through the access level that is being granted to him, he is able to read the data from the source. So what are the different objects that can be shared on this end? So that can be a database, tables, external tables, secure views, secure materialized views, and secure user-defined functions. So why is it called secure? So here Snowflake has made a very they have been very cautious about how the data is being shared. So let me explain you that the data that is shared is always read-only. Since the producer is sharing the data with multiple users, and there can be n number of consumers, we cannot allow the consumer to write back. So it is always read-only. And even when we are making it read-only, we need to make sure that we are sharing the specific data that is relevant to the, we are sharing the right data to the right consumer. And this is where the secure view comes into picture. So where we are through the DAC, so we are enabling that secured access to make sure that data is shared with the right consumer. So let me talk about how the same data, when 3 different accounts or 3 different users are accessing, they will literally see only their data and not others' data. So let's get on to that. So this is a very high level architecture or the explanation of how there is no actual data movement, but there is only a metadata that has been shared, and how through a secured view or a secured sharing, the consumer is able to access or consume the data that has been authorized or granted. Let's move on to the next one. Yeah. So now assume that so the data provider is now generating the data, and now you can see that there are 3 consumers here. You can call them as A, B, and C. So now there is 1 copy of data, and there is 1 copy of data in the producer end, and now there is 3 different metadata that has been created. However, when they fire a query, let's take an example of select star from orders, some order information that he wants to share with his retailers. And now when retailer A is trying to fire a select star from orders, so he should get only his data. Similarly, B should get only B's data, and C should get only C's data. So how is this implemented? So we need to understand all of them are connecting to the same copy of the data, and there is no multiple copies. It is just 1 copy, and this 1 copy and the data that is, they are all firing the same query, and ultimately each one of them end up getting their own data, and they are unable to see others' data. So this is where Snowflake provides an ability to create a user table which holds the credentials, and you have something called as a current account. When you try to query, when you use that where user is equal to current account, what happens is the query that you fire will always be compared with where the user is equal to current account. When A logs in, that current account evaluates to A. When B logs in, that current account evaluates to B, and so on for C. So what happens is when it evaluates to that specific current account, the query is filtered to pull in only that data, and that data is made available to them. So this is how the secured view or secured access is provided to the users. And again, when we are actually creating a share can be created where we can grant access on a database, grant access on a table or a schema or on a view. So when you grant access on one single view, and when you are sharing it, the end user who is consuming in his when he creates the database from that share, he will find only that shared view made visible at his hand, and he will be only able to access based on the authentication that has been based on the authentication and what has been based on the permission or the access that is granted for him for consumption. So this explains how the underlying architecture of the access is controlled and secured and preventing the misuse of data. Now you may ask me a question. So if a person shares the data and he consumes that, can he share that data with others? Obviously. So since that data is shared from the user and he is able to read that through the metadata, so he will be able to make a copy within his storage. So when he is writing it at his end, it now becomes his data. Obviously, he'll be able to share. So another concept is whether the same user can be a provider and consumer. Yes. So this is not one way. One producer can have n consumers, and there can be multiple producers servicing the same consumer. So it is 1:many, many:1, and many:1. So this implementation of the data sharing mechanism, it makes sure that we are able to consume the data that has been produced by multiple producers, and at the same time there are multiple consumers who are consuming the data from a single producer or multiple producers. Okay, so let's try to understand more about the sharing features. Let's move on to the next slide. Yeah. So what is the beauty about this data sharing mechanism? So we are literally making sure whatever we had faced, the challenges that we faced in the traditional world or the traditional approach. So where we had to construct the data and transfer the data over the network and then deconstruct it and then load it into the target. So here we are overcoming that complete process of reconstructing and reconstructing it. So we have a very secure, governed, and a resilient environment because there is absolutely data is not getting moved. It is just a metadata being created. And once the data is shared, it provides the capability of a full data warehouse. So another beauty about this is making the data available near real time. The reason is, imagine if in a traditional world, in the earlier picture we saw, when we had to copy the data or share the data, it had to pass through various activities before the data was loaded into the target. Imagine if the source, after moving the first batch of data into the target, and it underwent some schema changes, or the application went through some customization, and therefore the structure of the data got altered. Now you cannot push this data according to just as is into the target, because it will fail, because the target schema is not same now because of the changes that it has undergone. And this is one of the drawback, where we had to again make sure that target schema is aligned and intact with the type and size of whatever the schema that is being customized here before we copy the data into the target. And here the beauty is, since the metadata is being shared, any changes that here the producer makes, accordingly it is refreshed on the target, and thereby any new data that he loads and makes it available, it is instantly made available in the consumer's end. So it is providing a near real-time feature, a near real-time ability. So whatever the producer that he produces and just puts it into the share, it is instantly made available. That means to say, if there are two objects today and that two objects is visible in the consumer end, for the third object, he just has to put it into the share, and that's it. So when he refreshes here, he will find the third object is instantly visible, and he is able to consume that data. So some of the points that I want to emphasize on the data sharing capability. So what is the advantages? So let's look at some of that. Let's move on to the next slide. Okay, it comes to, so let me talk about that. Just move on to the previous slide. Right, I wanted to share like the keys so that you can have some takeaways from what data sharing can provide and how we were managing this in the traditional world, and how Snowflake has come up with a new architecture, literally overcoming every challenges with respect to the drawbacks from copying the data, to the silos of data, to the large volume of data moving to the target. So everything is overcome by this architecture that Snowflake has brought in. So let's try to understand that the the producer and the consumer. So basically, the Snowflake uses a term as outbound share and the inbound shares. So when the producer actually makes the data available for the consumers, that is called as the outbound share. And when the consumer is consuming that data, it is called as an inbound shares. So since we discussed about how a provider who is storing the data will only pay for the storage, and the consumer who is actually consuming the data, he need not pay for the storage, because he is literally not storing data in his end. He is only processing, running the query. He is paying only for the processing, the compute time. So therefore, the consumer will pay for the query that is being run at his end, again based on the time and the duration that he runs that query, and whereas the producer will just make sure he pays only for the storage of the data. And we also saw how the provider account, say for example today, one of the earlier one of the challenge they had was, since this data sharing works only within Snowflake accounts, so and it was limited to the same region. So the data sharing and the producer and the consumer had to be in the same region, and now they have leveraged that to have the replication copies in different region, and they have now made sure that it can also be consumed across regions now. So having said that, now we have a very clear understanding of how data was shared in a traditional world and how data is being shared through the Snowflake data sharing feature. So this is, and because of this feature, Snowflake has also come with a concept called a data marketplace, where now people are using this for monetizing the data, enriching their product capability, making their data and their data available to their consumers at their ease, to improve and see a growth in their business, to take immediate actions at their end. So this is now growing very rapidly now. So having said that, let me talk about one of the use cases that we had. So let's move to the next slide. So this is one of the education industry client. So this engagement was a two-part engagement. One engagement was to migrate the Oracle data to Snowflake. They had a huge volume of data in Oracle. They had to move to Snowflake environment because of the maintenance and the cost they incurred in managing that warehouse. The second outcome is to enable this data sharing capability. The reason is this education institution had about 20 colleges and deemed universities across different states, across the states in the United States. And they had the challenge whenever they were running certain advertisements to make sure what are the how many students are joining in each college, and what is the kind of expense they had for the advertising, how was the performance of the campaign. So all this, when they were running this through an agency, so they wanted to share the outcome of this with each of the college heads, the marketing departments, to measure their campaign performance and the cost that they incurred to run this advertising. So this is where there were through various social media channels and other sources where they ran this advertisement. So they collected a huge volume of data which was lying in the Snowflake warehouse, and from there they had to we had to extract the data to measure the campaign performance by each institute. and there was a lot of transformation and cleansing and making it available so that data can be leveraged by each of the marketing teams. So this data was made available through the data sharing, and every time they had this data being pushed here and the data processing, and once the data was shared, so the data was instantly made available to the marketing teams within the respective colleges. So this was, and this is an ongoing engagement, and the advantages, the outcome of this is the data sharing. We were able to share the data across institutions without moving the actual data to the targets. That is, they were having the access directly to the shared data, and they were able to achieve a near real-time accessing the relevant data. They were able to take the right decisions at the right time. There is no upfront hardware or software cost at the target end in order to get this. So, which is another advantage over the traditional approach. And the consumers as well, when they are consuming, it was a predictable subscription pricing. So where since it was internal, it was everything managed within the institution itself. So literally, the cost that they incurred to manage this kind of analysis in each of the college or institute, because of this data sharing mechanism, we saw about 40% reduction in the maintenance cost for the client. It also enabled quick insights that they could take action at the right time, which increased a 10% increase in the top line with a high reliability and scalability. And definitely another advantage that the institute observed or they leveraged is the implementation of the auto-scaling features. So as new departments were added, new sources were added, it was instantly able to scale up because of the kind of model and how the data could be instantly shared, which is made available to the consumers. So having said that, so let me move on to question and answers. I believe I'm not sure if I was very fast, but I hope you really got the crux of what the data sharing is, what are the challenges today, and how Snowflake has overcome that using a very unique features and the kind of architecture they have built without sharing the actual data. They were able to achieve it. And one of the beauty of this is because the data, there is only one copy of data which can be shared with n number of accounts. If your question is there any limitation on sharing with number of users? There is no limitation. That can be n number of consumers, since they're all hitting the same data from the producer end as well. He'll be able to measure who is actually accessing the data, which table is being more frequently used, and all that kind of analysis can also be performed. So now, having said that, let me take up some questions. So we have left with some more time. So I'll be happy to answer them.
Thank you so much, John. These were great insights. So now we are ready to ready to take any questions you have. So the first question we have got here is, can the Snowflake data sharing option work out of the Snowflake environment?
If the question is whether we can work out of Snowflake, no. This is designed to work within the Snowflake environment. So the answer is no. The producer and the consumer concept is tied within the Snowflake environment. However, the beauty about that is, which was earlier within the region, is now scaled up to other regions as well. Though there is alternate way of implementing it, but they have made sure that the sharing can be done across the region. But to answer that, it works only on Snowflake environment and not outside of that.
Thank you so much, John, for that answer. Another attendee has asked, like, what size or kind of companies can benefit from data sharing?
The size and kind of companies, since Snowflake is designed to address from small to medium to large companies. So there is really no limitation. The reason is, even if you look at the kind of the virtual warehouses that Snowflake architecture has been designed, it is based on the kind of volume of data that you are processing. It chooses the right virtual warehouse. If it is a small data, it chooses a small virtual warehouse. If it is a medium, it chooses a medium virtual warehouse, and if it is a large, it chooses a large virtual warehouse. So and thereby, so it is a right fit for any kind of organization, any size organization can benefit from this data sharing method. Yeah.
Thank you so much for the answer. Another attendee of us has asked about the data sharing consumer. Like, is it mandatory for a data sharing consumer to become a Snowflake customer?
I think in one of the explanation I gave that. Not necessarily. If a Snowflake consumer is already a customer, then he'll be able to consume it. Otherwise, the producer itself can produce or create a reader accounts. So when I was talking about the producer and consumer concept, there are two types of consumers, and one is the reader consumer, a reader consumer account, and the other is a full consumer account. When the consumer is not a Snowflake customer, he can be a reader consumer account, which can be where the reader consumer account can be created by the producer itself. The only difference is now, since the storage and the processing lies with the producer account, the consumer, when he is running his queries, the charges are now the cost to the compute cost is now charged to the producer. So what internally it happens is, so now the producer can measure what is the compute cost for that respective consumer, and he can invoice it back to the consumer. So that is how it works.
That's great. So I'd like to remind my audience in between that they can post the their questions with the question mark at the top right, and we are taking questions. So you're free to post any questions in case you have. So the next question for you, John, is how much time does it take to implement data sharing for a company?
So we saw that how it is completely automated. Comparing it with a traditional way of sharing the data versus the underlying architecture that Snowflake has built, we can literally see that it is one important step here is good. This is a good question. So I didn't talk about how the share is created. So there are 3 steps involved while sharing or performing the data sharing. First is you need to create a share, and second step is you need to grant access on the specific objects that you want to share. So you have to grant access on that specific objects to the share you created. And the third step is, and to this share, you need to add the accounts. So accounts is basically the consumer accounts. So whoever is added to the share, so whatever objects is being shared by the shared into the that is made available to the share, the consumer will be able to access. So thereby, having said that, the implementation time is very negligible. It is just a matter of the time. All the time it takes is for the producer to make sure the data that he has got, he has transformed, massaged, and consolidated in a way that it can be presented to the consumers. And once he makes that data made available for sharing, it is just a matter of consumer to directly just create a database and create the metadata out of it. And once the share is, when the account is added to the share, he is able to instantly read the data. So it can last somewhere a few minutes if everything is in place.
Okay, I hope that answers the question well. Another question from one of our attendees is that how can we share sensitive data externally?
Right. So, first of all, Snowflake enables only secured access. That is, we cannot have all of the data shared, made it available to all the consumers. So when we are sharing the data, Snowflake has enabled a concept called secure. So when you create a view, it is created as a secure view. That means to say only secure views or secure material used views or secure user-defined functions. So these are identified as the shareable objects. And when we are creating a secured view, we need to make sure that we also add the specific account who wants to have access to it. And thereby, I was talking about a concept called DAC. that is the data access control. The data access control layer is the one which enforces that security to make sure that we have the right authentication or the right access being granted to the right consumer. So this enables, so if you have hundreds of consumers and you want only 10 consumers to have access to a specific view, when we create this secure view and we grant access on this view, and we add only those 10 accounts into the share, so that rest of them will not have access. Only the 10 users who have been granted access will be able to share or consume this data.
Thank you, John. I hope that answers the question, and great insights again. The next question is like, what is the maximum number of consumer accounts that can be added to a shared object? So one of our curious attendees wants to know that what is the maximum number of consumer accounts you can share to, you can add to a shared object?
So basically, since Snowflake architecture itself is so scalable, it has no restriction on the number of consumer accounts. So there is no limit to the consumer accounts. You can create a share, you can define or grant access on a specific objects, and you can add n number of accounts to that share. So as long as you are able to create the consumer accounts and add them to the share, all of them will be able to access. The beauty about that is why it is so simple. Why is it there is no limit, hard limit on sharing? See, the beauty is we are not making a copy of the data. If there was a need to really make a copy of the data, move the data, where in the traditional world where we had to move into the Excel file and encrypt it and transfer it over the FTP, and then again once it is transferred over the network, we had to again collect it and then decrypt it and then kind of bring it into the CSV or the Excel and then load that data. So imagine the time and the effort that is there to load the data, and imagine if you had about 1,000 consumers. Imagine the effort and time required to really copy that data for the thousands of consumers over there. In this case, there is no movement of data. There is no data being copied over in the target, in the consumer end. They are only they only create the metadata and they reference, they point to the same copy of data that is there in the producer end. And thereby, since there is no need for, since there is no data movement happening, there is no restriction of how many accounts or how many consumers wants to access. It's just a matter of they need to have the appropriate access, and those accounts have to be added into the share, and then that's it. They are able to consume the data.
Well, that's great. So another question we have from a user is from our attendee is, what type of cost should the consumer bear or pay?
Yeah, so this is mainly since Snowflake provides pay-per-use basis, and very wonderfully they have separated the compute cost and the storage cost. So one can incur, if somebody is just storing the data and not doing any processing, they just pay for the storage cost. And somebody who is running the query will only have to pay the compute cost. So here, the cost is for the producer who is actually producing the data and he is storing the data in a warehouse or his share house, which is to be shared, he pays for the storage cost. And whereas for a consumer who is consuming the data, he is not actually storing the data, he is only reading the data. So therefore, he runs queries. So the queries that he runs, he just have to pay for the compute cost for whatever time that he is running the query. And this is the example that I had explained earlier as well, the two different kinds of consumers. One is the reader account and the full consumer account. Who bears the cost when it is a full account, full consumer account, and who bears the cost when it is just a reader consumer account.
So we are at the top of the hour, but we can take the last question now from John. John, the last question we have from our attendees is, what are the different types of consumers in Snowflake data share?
That's exactly what I was talking about now. So we have the reader consumer account, and we have the full consumer account. So these are the two types of consumer accounts. So primarily they differ in the way who bears the cost. In the reader account, the cost is charged to the producer, who in turn can invoice it back to the consumer, because he will be able to measure what was the consumption cost for that specific consumer. Whereas in a full consumer account, the full consumer account, since he is already a Snowflake customer, he can use his own account to read, and therefore the compute cost is charged to him. So it is the reader consumer account and the full consumer account are the two different types of consumers.
Thank you so much, John, for clearing all the questions, and I hope that answers our attendees well. Well, thank you for being a part of this webinar today, and we hope you have some takeaways from this session. Thank you, John, for your time today. Before closing, I would like to expect this webinar replay in your inbox within the upcoming 3 to 5 working days. Thank you, everyone, for your time today. Have a great day ahead.
Thank you all. Hope you enjoyed it.